Okay, I just wanted to take a second and to go through all the different information you need to know about the median, perpendicular bisector, angle bisector, and altitude in a triangle. The first is you need to make sure you know how to construct each one. A median, remember, is the segment from the midpoint of a side to that opposite vertex. A perpendicular bisector also goes through a midpoint, but it's not through a vertex. It's actually perpendicular to the side that the midpoint is on. That one is the one that you don't need to know. It doesn't have to be a triangle to find it. A median has to be a triangle because you need the vertex. Perpendicular bisector can be any segment. Angle bisector cuts an angle in half. And then the altitude, you go through a vertex, but then it's perpendicular to the opposite side. It does not go through a midpoint. All right, about two of these, we have a theorem. And so the perpendicular bisector theorem said any point on the perpendicular bisector is equidistant from the endpoints of the segment. Okay, and then the angle bisector theorem says any point on the angle bisector not equidistant to the endpoints of the segment because there are no endpoints of the segments. Instead, it's equidistant from the sides of the angle. And then those two inform us about what we learn about their points of concurrency. All right, each one of these, when you draw all three of them in, those three lines all intersect at a single point called a point of concurrency. The median, the point they intersect at is the centroid. The perpendicular bisector is always the circumcenter. Angle bisector is always the incenter. The three angle bisectors meet at the incenter, and then the altitudes all meet at the orthocenter. Okay, the median, there is a theorem about this point of concurrency. The centroid, besides being the center of balance, which we showed when you drew in if you cut out a triangle and draw in the medians and find the centroid, you can balance the triangle at that point. But it also has that theorem that says it's 2/3 the distance from the vertex to the midpoint, which means when you draw in a median, if you go 2/3 the distance from the vertex to the midpoint, there is your centroid. Which also means from centroid to midpoint, you multiply that by 2, and that gives you the distance from the centroid to the vertex. All right, perpendicular bisector, if you remember, the points are equidistant from the endpoints. Well, the endpoints of our segments are actually the vertices of the triangle. So the circumcenter is actually equidistant from the vertices of the triangle. And then we have a circle called the circumscribed circle that of the triangle that goes through those two vertices. And so it turns out that the circumcenter gives you the center of the circumscribed circle. The angle bisector, remember, is equidistant from the sides of the angle, which is also the sides of the triangle. And so it's equidistant from the sides. And it's also the center of the inscribed circle, which is that circle, that biggest circle possible inside the triangle that rests up against the three sides. And then finally, the altitude has no theorem about it. The last thing is the Euler line. Remember, the Euler line comes from we learned about it when we were learning about the 9-point circle. And the Euler line is actually the centroid, the circumcenter, and the orthocenter are all on the Euler line. The incenter is not on the Euler line. The Euler line is actually the segment connecting the circumcenter and the orthocenter. Those are the two outside points. The centroid is between those, and then the fourth point that's on the Euler line is the center of the 9-point circle. So that gives you a lot of information all in one way, hopefully help you remember it. It's important to know these different facts about these different lines and points of concurrency.